Hello, I'm Laura Marshall.
And I'm Krista Zanoli, and this is Light Matters for November 23rd, 2011. In this week's 5 Minutes to Enlightenment, neutrinos may not travel faster than light after all. NASA decides not to kill the messenger. A new material emits near-infrared light, and a new single-layer structure improves quantum dot LEDs.
At the end of September, Light Matters reported on the Opera experiment at the Gran Sasso National Laboratory in Italy, where scientists said neutrinos from Switzerland's CERN Research Center arrived at their doorstep 60 nanoseconds before light could have, effectively outrunning the speed of light. The announcement called into question the validity of Einstein's special relativity theory, which said the speed of light cannot be surpassed. But a new study released this Saturday by the Opera team's colleagues at the Icarus project rejects that finding, according to Reuters News. Studies last week supported the original findings, but the Icarus team says its measurements of the arriving neutrinos' energy levels, quote, refute a superluminal or faster-than-light interpretation of the Opera result, end quote. The neutrinos, they say, should have lost most of their energy on the trip from CERN if they were indeed traveling at even a tiny bit faster than light. But they found that the energy of the arriving neutrino beam lined up with what it should have been for travel at the speed of light, no faster. Researchers at other labs around the world are preparing to test Opera's findings.
NASA said last week it will not kill the messenger spacecraft, that is.
Terminal phase, 15 seconds. Locks topping now, underway. Green board, 10, 9, 8, 7, 6, 5, 4, 3. Main engine start, 2, 1, and 0, and liftoff of Messenger on NASA's mission to Mercury, a planetary enigma in our inner solar system. Pitch program is in, roll program is in.
Messenger entered orbit around Mercury on March 18th, and its primary mission was scheduled to end on March 17th, 2012. Funding details are still being ironed out, but NASA scientists say the extended mission will allow them to learn even more about Mercury by spending time closer to the planet. Among the photonic instruments the spacecraft carries are the Mercury Dual Imaging System, which gathers topographic information, the Gamma Ray and Neutron Spectrometer, which seeks emissions from radioactive elements on Mercury's surface and from surface elements that have been stimulated by cosmic rays, and the Mercury Laser Altimeter, which charts the planet's topography.
While visible light emitters are commonplace, there has been little success in creating materials that emit light in the near-infrared range until now. A new material developed at the University of Georgia emits a near-IR glow for 2 weeks after a single minute of sunlight exposure or even exposure to fluorescent lights. The current recipe for the material is a foundation of chromium ions mixed with zinc and gallogermanate. Its creators say that it can be built into nanoparticles that bind to cancer cells, letting doctors see small metastases that might go undetected. For military and law enforcement uses, the material can be fashioned into ceramic discs that serve as an illumination source seen only by those wearing night vision goggles, or it can provide the foundation for highly efficient solar cells.
And in business news, Christopher Cox, former chairman of the Securities and Exchange Commission, has joined the board of Newport Corporation. Cox, a partner in an international law firm and president of its subsidiary, is a former congressman and a White House counsel. Leica Microsystems signed an agreement with the Max Planck Society and the German Cancer Research Center to develop gated stimulated emission depletion microscopy, or gated STED, the next generation of the super-resolution technique. Leica Microsystems will commercialize and market the new technology. With gated STED, Stefan Hell, the director of Max Planck Institute for Biophysical Chemistry, has taken ZW STED a step further, improving its resolution and contrast while distinctly reducing laser intensity. The main application of gated STED technology will be observation of molecule movements in the living cell membranes. Leica Microsystems expects to launch the new product in the first half of 2012.
Harvard researchers have demonstrated a new, more versatile design for QD LEDs by nestling quantum dots in an insulating structure that resembles an egg carton. The new design could expand applications of QD LEDs in displays, lighting, and lasers. Ligands, organic molecules that dangle from quantum dots, are essential to quantum dot growth, but they can interfere with current conduction and cause functional problems later on. Quantum dot technologies developed so far have been big, thick, multi-layer devices because multiple layers are essential for producing enough light. But all those layers don't allow much control over current conduction or flexibility in terms of chemical treatments. The new QD LED resembles a sandwich with a single active layer of quantum dots nestled in insulation and trapped between two ceramic electrodes.
Well, that's it for this week's edition of Light Matters. You'll find more on all of these stories at Photonics.com. We'd like to hear from you. Please share your comments and story ideas with us. Our email address is lightmatters@photonics.com. You can also follow us on Facebook and Twitter.
Thanks for watching, and remember, it's only 5 minutes to enlightenment. Bye.